Good morning. We are team number 5. First of all, let me present my group, my work team. Mr. Pritesh Pardeshi, Humberto Mejia, and myself, Alfonso Parra. Our project consists of the humanoid robot design. We select the following content: the initial survey results, selection, problem statement, project plan, humanoid robot components, part specifications, design concept of robot assembly, robot turning, problem limitations, tags and timeline, and conclusion. When we decided to assemble this particular robot, we knew it. This kind of robot is used in different aspects for several scientific areas. For example, the space exploration missions, entertainment, personal assistant, and a series of dangerous dealing applications. The problem statement in this particular project, we know the robot can walk in the straight line and turn to the light on the right side. Also, the robot can do the series sequences of the motion, and using the graphical user interface can be accomplished by the IR of remote control. When we decided to design the humanoid robot, we started from planning the selection, design concept, kinematics and structural analysis, get components and parts, robot construction, controlling and software development, testing and experiments, design improvements, and final design. The specification for this particular robot, the height is around 13 inches. The weight is 1.2 kilograms, include the battery. The controlling by 18 mega, 32 and 16 PU microcontroller. This robot has 24 available channels, and the battery is the 6 volts, and the charger is the 7.2 volts.
The robots, I'm sorry, my voice is sick. The robot components, we use 3 types of servos. The 4104, the powerful servo, it was using the lower legs. The 4032, we use 15 servos of this, and 2030 is we use only 3 of these. The microcontroller used was the 80 mega 32 with the 24 servos channels. The IR remote control and the PC board were the other important parts. The robot is the robot design concept is basically the humanoid robot with the arms, torso, and its legs. About the assembly, the first step to assembly was to assemble the arms. When we install any servo, we have to tune everyone with the PC board connected with the battery. the second step was assemble the right and the left and the right leg at the same operation. When we finish to assemble, we tune every servo in this part. Finally, we assemble the body. The body has 2 servos for shoulders and the other 4 servos for the body. That's it.
Thank you. As Humberto said, that the main body, the torso part, basically, it consists of a body. The body part which is shown on the top left, it basically shows the main holding structure for the complete robot. The second, as you go clockwise, the black shaded part shows the part on which the microcontroller is installed. Then down, there is a shaft in the center that acts like our vertebral column. It acts as the same way to keep the balance between the left and right sides of the robot. And as you can see in the bottom left, we have attached the microcontroller on the back as on the black shaded area. The next part was the tuning of the robot assembly. Well, this was the part. This was the most difficult part to do because we had an idea that when we assemble the complete robot, we should whenever we restart the microcontroller, it should get to its initial position so that we can refer to as a starting point or a starting location. For that purpose, we used 3 different kind of parts. As you can see, the first part, it was circular rims. It had 8 holes, each of 45 degrees angle, and they were marked with alternate small and large holes for easy to change the angle by 45 degrees. The second part was the holder which we used, and the holder which we used coinciding with the circular rims as we shown in the first part. And the third part, the main part was the 90-degree marking on opposite ends of the holder. This part actually made a lot of easier to tune the robot because if we hadn't used such robotic parts, we might had more problems for the robot tuning. As I said, we had some problems while assembling the robot. The first problem we had was the assembly of the main part, that is the assembly of the torso region. The problem which we actually went through while assembling the torso part was that it was very tedious and it was time consuming. The reason for that was because the torso part is very small, but actually it's the main part of the robot, so we had to use a small size of boards, and that was very time consuming and tedious. The next problem we had was the tuning of each arms and legs. Once we assembled separately each arms and leg, the next part was to tune in with the main torso region. The problem we had while tuning, although we had three parts that we described earlier for tuning, we still had a problem because the same reason as the first one, that they are very small parts, and to the tune exactly 90 degrees or 180 degrees or 45 degrees, it was a bit time consuming and a not so easy part. Another problem we had was the balance of the robot. Although we ordered parts of less weight, we still had problems with the balancing of the robot. Actually, we still have a minor problem with the balancing of the robots. We actually overcame the problem, but we had another problem with the battery, so we changed the battery, and that's why we had the we again came back to the same problem of balancing. What we did is, initially the battery was not installed, and the battery was on the a little bit of left side of the robot, and now when we change the battery, we install it in the center, so that it will approximately will be at the center of gravity. These were the problems. We mostly came across. We mostly corrected the problems. The task which we are going to perform, the basic robotic task of forward and backward motion, right and left turn, is recovering from the fall position, sleeping mode, and we have also designed a routine, a sequence using the computer interface, which I am going to show you right now. The timeline that we planned, pretty much we are going according to the timeline. And to conclude our project, I would like to say that while doing this project, we came to know across many details of the humanoid robot, and not just that, we also came to know a lot of applications for the humanoid robots. And now we are going to show you a demonstration. Well, in this demonstration, the robot will walk forward, it will go to sleep, and it will wake up from its sleeping position. As you can see, we have a little bit problem of balancing. And we also had the same problem as the other team with biped. When we do the demonstration on this kind of surface, it kind of slips, and when we do it on this kind of surface, it performs it pretty well. Now I'm going to show a demonstration of a sequence. Well, now when I start the microcontroller, it will go to its initial reference point. Now we will try to do a sequence, but we have some problem with the battery. We actually also had a sequence for walking, but due to its balancing problem, we had it. Luckily, we had it on the video. But we cannot show it right now. Okay, and so that's it.